Welcome everyone. And now the topic of today's discussion is what is a chemical equation? In this lecture, we will discuss what is a chemical equation and we will also discuss the merits and demerits of a chemical equation. Now, what is a chemical equation? A chemical equation is basically a symbolic representation of a chemical change in the form of formula of the reactants and the products. For example, if I say that hydrogen reacts with oxygen to form water, it will require more time and it will also require more space to write it down. But simply I can write it down that H2 plus O2, they react together to form H2. This is symbolic representation of a chemical change in which the hydrogen and oxygen they react together to form water. Now, in order to balance the chemical equation and to fulfill the law of conservation of mass, I will have to write 2 here and 2 here. Now, this equation is balanced, means it is obeying the law of conservation of mass, which is the foundation of the science of the chemistry. So, in the form of formula, we represent a chemical change that is called as chemical equation. What are the merits and demerits of a chemical equation? So, first of all, let us discuss the demerits. A chemical equation does not provide information about what? Number one, conditions of reaction. Under what conditions the reaction is being carried out? What is the temperature? What is pressure? Whether the catalyst will be used or it will be without catalyst. So the conditions of a reaction, they are not mentioned, they are not told by a chemical equation. Whenever we write on an equation, we write some chemical conditions here, but those chemical conditions are not provided by the equation, but that information is provided by the experiment, that what conditions should be there for the optimization of a chemical change. Now the second thing, that is rate of reaction. A chemical equation provides no information whether the reaction will be slow or fast. Even there are some reactions that are explosive. So we must have an idea that whether a reaction is slow or fast or even it is explosive, but this idea is not provided by the chemical equation. Just looking at this equation, I cannot tell whether this reaction will be fast, slow or explosive. Number 3, a chemical equation does not provide us information about the physical states of reactants and products. Whether the reactants will be in gaseous form, liquid form or solid form. Whenever we write an equation, we have to separately write in the subscript of these reactants and the products what physical condition they have. Whenever we write gaseous, liquid, this information is not provided by the equation, but we direct the equation that what will be the physical state when we will be performing this chemical change in the laboratory. Number 4, the fourth limitation, chemical equation does not provide us information about the heat involved in a reaction. Whether a reaction is exothermic or a reaction is endothermic, this information is not provided by the balanced chemical equation. The fifth one, whether the reaction will be reversible or irreversible. When I say that hydrogen reacts with oxygen to form water, I have no idea. I have written this in the form of the symbols, but I have no idea whether this reaction will be unidirectional or this reaction will be bidirectional. So this information is also not provided by the balanced chemical equation. These are some demerits of a balanced chemical equation, that disadvantages, limitations of a balanced chemical equation, that a balanced chemical equation does not provide us information about these five parameters of a reaction. Now, what are the merits of a chemical equation? There are certain merits of a chemical equation. First, short form. The chemical equation, when we symbolically represent a chemical change, that reduces the time to write it down, that reduces the space to write it down. So that is the first advantage of the chemical equation. Second, universality. We are the resident of a global village, and the people in the different areas of this village, they have different native languages. There are so many people that will not be having any idea of English, that will not be having any idea of Urdu, Hindi, Persian. But whether there is any area of the global village, whenever the reaction between hydrogen and oxygen will be shown, the language will be this one. Whenever we will show that hydrogen and oxygen react to form water, it doesn't matter where we are living, we will show that chemical change in this form. So the chemical equations are a universal mean of showing the chemical changes. They doesn't make any difference with the language we belong to. The third and the most important merit of a chemical equation is the study of quantitative relationships. With the help of chemical equation, I can study the quantitative relationship of the reactants and products. If I know the quantities of the reactants, I can predict what quantities of the products are going to be formed. And if I know the quantities of the product that I require to form, then I will have an idea that how much reactant will be needed to produce this quantity of the products. So the most important aspect of a balanced chemical equation, when I say balance, it means the law of conservation of mass should be fulfilled. The most important aspect of a balanced chemical equation is the study of quantitative relationship. And when I say that this is the most important aspect of a chemical equation, then I will discuss it in detail. So the study of the quantitative relationship of the reactants and the products, this is the basic advantage of a chemical equation. And whenever I say that the study of the quantitative relationship, a word hits my mind, that is the stoichiometry. This is a word which is pronounced in many different ways. Some people say it is stoichiometry, some say it is stoichiometry, and some say it is stoichiometry. So pronunciation is not important, but you must have a concept, strong concept, what is meant by the stoichiometry actually. Stoichiometry is basically combination of two Greek words. And those two Greek words are Stachyon and metron, or metra sometime it is written. Stachyon means elements and metron means, or metry means, or metra means measurement. So I will say that stoichiometry is the art of measuring the chemical elements. Now this is the etymology and the meanings of the word of the stoichiometry, but how can we define stoichiometry? Stoichiometry is basically defined as the study of quantitative relationship between the reactants and the products according to the balanced chemical equation. So the foundation of the stoichiometry is actually balanced chemical equation. And when I say balanced chemical equation, I can also say that the foundation of the stoichiometry is basically law of conservation of mass. Now, how many relationships can be studied? I will give an example. Suppose A moles of A, B moles of B, they react together to form C moles of C and D moles of D. IUPAC defines a way to read a chemical equation, and IUPAC says that this positive sign that will be read as reacts with or react with, this arrow will be read as to yield, and this will be read as and. So I can read this chemical equation: A moles of A react with B moles of B to yield C moles of C and D moles of D. That is basically a way of reading the equations, and this way is provided, this principle is provided by the IUPAC, International Union of Pure and Applied Chemistry, IUPAC basically. So I have taken an example, this is an equation. What stoichiometry means actually. If I know the quantity of A, using this chemical equation, I can predict what quantity of B will be required to react with the given quantity of A. So this relationship will be called as reactant relationship. Reactant relationship means quantitative relationship between two reactants. If I know the quantity of A, I can also predict that from given quantity of A, how much amount of the C or D can be produced. So this relationship will be called as the reactant product relationship. And if I know that this quantity of C has been produced, then I can also predict that if this amount of C is produced, how much amount of D will be produced with it. So this relationship will be called as the product relationship. Reactant product relationships can be discussed by using the balanced chemical equation. Now these relationships, basically depending upon the nature of the quantity which is in our consideration, these relationships can be further described as mass relationship. Mass relationship means mass of one species is known and the mass of other species is required. Now this one species whose mass is known, it may be a reactant, it may be a product, and the other species whose mass is required, it may also belong to any of the two categories, whether it can be a reactant or it may be a product. Similarly, mass mole or mole mass relationship. Now this mass mole and mole mass relationship, what is the difference between these two? If the mass is known and mole are required, then this is mass mole relationship. But if mole are known and mass is required, then that will be called as the mole mass relationship. So the quantity which is given, it is written first, and the quantity which is required, that will be written after it. The next one is mass volume or volume mass relationship, and the last one is mole relationship. So these four relationships are actually describing that what are the quantities, nature of the quantities in which we are discussing this chemical equation, whether in terms of masses, in terms of moles, in terms of volume. But these relationship, they define that what relationship is going to be discussed. Either it is between two reactants, between two products, or between a reactant and a product. These are called as stoichiometric relationships that can be discussed by using the balanced chemical equation. Now you can see some coefficients written with these reactants and products. This A is a coefficient of A, B is coefficient of B, C is coefficient of C, and D is coefficient of D. These coefficients are basically called as stoichiometric coefficients. These coefficients are basically the stoichiometric coefficients. Now, what kind of information these coefficients provide? Basically, these coefficients provide us the information about the moles or particles. Means, I can read this equation in two ways. A moles of A react with B moles of B to yield C moles of C and D moles of D. But I can also read it as A molecule of A react with B molecules of B to yield C molecules of C and D molecules of the D. If it is a molecular substance, otherwise depending upon the nature of substance, the term atom or molecule or formula units that can be used. So stoichiometric coefficient provides us information about the number of moles or number of particles. But let me tell you one thing very important, that what are the stoichiometric coefficients of the reactants? They are A and B. What are coefficients of the products? They are C and D. But whenever we write the stoichiometric coefficients of the reactants, we will write symbol negative with them. And with the products we write the sign positive. Actually, this negative and positive is just showing us that the reactants are being consumed and the products are being formed. So instead, it is a convention. Instead of writing A, we will write it down minus A. Instead of writing it down B, we will write it down minus B. Similarly, in case of C plus and D, positive signs are used. The negative sign with the coefficients, they just provide us information that the reactants are being consumed, and the positive sign with the product just provides us information that the products are being formed, nothing else. Now stoichiometry, whenever we are studying the stoichiometry of any equation, we are dealing the quantitative relationship according to equation. There are some assumptions that we will have to make. And those assumptions are, what are basically those assumptions? Number one, the first assumption is all reactants must be changed to products. What does this assumption actually means? We can read it and we can also memorize it that all reactants must be changed to the products, but what actually it means? I think so it simply means that the reaction must be irreversible. You know, all the reactants are converted into the products only in case of irreversible reaction. If the reaction will be reversible, then all the reactants can never be changed to the products, but the products will re-react to form the reactants. It means stoichiometry deals the irreversible reactions, but now there is a problem that if the reaction is reversible, then what will we do? If a reaction is reversible, then the stoichiometry of the reversible reaction is studied under the heading of chemical equilibrium. So the stoichiometry of the reversible reactions is studied under the heading of chemical equilibrium. Here, when we will only say stoichiometry, that will only refers to the irreversible reactions. The second one, if we are dealing the gases, mean the reaction involves the gases, just like the combustion of methane, a very common reaction that is taking place in our kitchens and in the vehicles. If we are dealing the gases, then it is assumed that the gases must be ideal. Gases must be ideal, and their temperature, their pressure, and their volume are known to us. That is basic assumption of the stoichiometry when we are dealing the gaseous phase reaction. Third one, two laws, but that is not an assumption, that is the foundation of the stoichiometry, that the law of conservation of mass and law of definite proportion, that must be obeyed. So in this way, we can discuss the quantitative relationship between the reactants and the products. These are two assumptions, and this third one is basically not an assumption, but it is the foundation on which the pillars of the stoichiometry stand. I will give an example how these quantitative relationships are actually discussed. And I will discuss it in the form of an MCQ. First of all, I will write down the options. The A option is 8 gram, 16 gram, 32 grams, 24 grams. Now what is the question? If we have 27 grams of aluminium, then how much oxygen is required to produce alumina, or you can say Al2O3. But the question is, we have 27 gram of aluminium and we want to produce Al2O3, then what mass of oxygen will be required? Because the stoichiometry is totally based upon the balanced chemical equation, then how can you think to perform any calculation without writing down the balanced chemical equation? So first of all, but in order to balance it, now this one is the balanced chemical equation. If you actually want to perform the stoichiometric calculations in a very perfect manner, then you must have a trick, or you must have an idea how to write a balanced chemical equation. According to this balanced chemical equation, the 4 moles of oxygen require, the 4 moles of aluminium require 3 moles of oxygen to completely react with one another. Now what mass of aluminium is given to us? That is 27 gram. And 27 gram means 1 mole, because 27 gram is the molar mass of the aluminium. So we actually have 1 mole. The equation tells us that 4 moles of aluminium completely react with 3 moles of oxygen, but we have 1 mole. So 1 mole of aluminium will react with how much oxygen? That will be 3 by 4 mole. Now we have moles of oxygen that will react completely with 27 gram or 1 mole of aluminium. But the mass is required. Now you know that the mole is equal to mass in gram divided by molar mass. And if the moles are given, how the mass is calculated? By multiplying it with the molar mass. That is the rearranged form of that formula. Number of mole is equal to mass in gram divided by molar mass. So 4, 8 and 8 into 3. 24 grams. So the correct answer is delta. Now let me tell you one thing more, that what kind of relationship it is. It is reactant, reactant, reactant product or product, product. I think so that the mass of aluminium was given and the mass of oxygen was required. So this is reactant, reactant relationship. And in terms of quantities, what type of relationship it is? It is mass mass relationship, because mass was given and the mass was required. So in this way we can perform the stoichiometry calculation, and stoichiometry is very 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 important for us, because having idea of the stoichiometry we can perform a chemical reaction in a much better and economical way. If anyone asks you that what is the main purpose of the stoichiometry, so keep in mind that main purpose of the stoichiometry is to make a reaction economical. The main purpose of the study of the stoichiometry is to make a reaction economical. With the minimum wastage of the reactants and with the maximum yield of the product, we can make a reaction economical, and that is the main purpose of the study of the stoichiometry. So this was all about what is a chemical equation and what is stoichiometry. But under the heading of stoichiometry, we also discussed two other topics. One of them is the limiting reactant and second one is the yield. These two topics are also discussed under the heading of the stoichiometry, and we will be discussing them in the next lecture inshallah. Till then, Allah Hafiz.